Today you are going to be looking at learning target 6D, where you are solving a system of inequalities. Before we can start, you need to make sure you have your Cornell notes set up. Make sure they are titled 6D, Solving a System of Inequalities, so that you can reference them on a quiz or test down the road and know exactly what you're looking at. The second thing is to help you focus your attention and focus in on the things that you need to write down versus the things that you just need to pay attention to. There is a difference based on the title on the screen. If the slide title is written in plain black, it is something you do not need to write down. You simply need to pay attention to. If the slide title is written in purple and bold, it is something you need to write down and make sure you have in your notes. So again, if it's just plain black, make sure you are not writing it down and just paying attention, and if it is purple and bold, make sure that you are writing it down. So the first thing, obviously, in black means we just have to pay attention and refresh our memory. Before we can graph inequalities, we must remember how we graph lines. So if we have the equation y equals 2 over 3x plus 5, we know that we have a slope of 2/3, because slope comes in front of x, meaning it is up 2 and right 3. And our y-intercept, we start at the point 0, 5. So if you look at the graph on the right, if you go up 5 units, that's where our y-intercept is, and from there you would move up 2 and right 3 and follow that pattern to get more points on your line. This you do need to write down because it is purple and bold. So we want to make sure that we're very clear on what each of our inequality symbols mean and what that tells us to do when we graph a linear inequality. So we first have the symbol less than, okay, which looks like this, and whenever it's less than or greater than, so down here, we have a dashed line. So in this case, less than has a dashed line, and because it's less than, we shade below. If it's less than or equal to, it is a solid line. Remember when we had that little bar that represents equal to or greater than or equal to, it becomes a solid line. And again, it's less than, so we shade below. Greater than will be a dashed line, and we will shade above. And greater than or equal to is a solid line, and we will shade above. This table will help you make all those decisions when it comes time to graph and shade your line. So you'll want to make sure you have it for your reference. Now, you also want to write this down because we want to remember what happens if our problem is written as an inequality rather than an equation. So in this case, we don't have the line y equals 2 over 3x plus 5. We have the line y is less than 2 over 3x plus 5. So first off, we know that because it's less than, it's going to be a dashed line, and we're going to shade below. So we do the same thing. We have our same y-intercept, same slope, up to right 3, and we follow that pattern to build our line. And then we know, okay, I'm going to use a dashed line, so we've created a dashed line here. And we know we're going to shade below, so every point shaded below is part of our solution. If you were to check, the point 0, 0 is in our shaded region. 2/3 times 0 is 0. 0 plus 5 is 5. If we plug in 0 for y, 0 is less than 5 is a true statement, which is why that is part of our shaded region. The same could be true for the point 1, 2, which is right here where the cursor is. That point, if you plug in 1, 2, x is 1, so 2/3 times 1 is 2/3 plus 5, so 5 and 2/3, or 5.66, is greater than 2. That's a true statement. So again, that's in our solution region. Any point that is in our shaded area is part of our solution area. Let's try one more example of when we have a linear inequality, meaning there's not an equal sign, but rather an inequality symbol. In this case, we have y is greater than or equal to negative 4x minus 1. Here, our negative 4 slope means we're going to move down 4 and again to the right 1. Remember, when there's no number underneath this initial coefficient, we always know we're going to move to the right one. And our y-intercept is at -1. So we plot our point down here at -1, and then we move down 4 to the right 1, and we can follow that pattern to create our line. From there, we look at our table and say, okay, since it's greater than or equal to, we know it's going to be a solid line, and we're going to shade above the line going this way. So we've done all of that. Now, the key here is to now create our system of inequalities. Now, our system of inequalities is really just two different inequalities laid over the top of each other, and we look for where the shading overlaps. So if we were to take our initial graph of y is less than 2/3 x plus 5, and our second graph of y is greater than or equal to -4x minus 1, and lay them on top of each other as seen on the right, the spot where the shading overlaps is this purple area. So that is the area that we shade permanently as our solution. Again, we shaded below the first line, above the second line, and so the part where that is true and holds true for both lines is right here represented in purple. Okay, that is an example of when we're graphing a system of inequalities, which is the learning target today. Now let's try one more example of a system of inequalities. We have the inequality y is less than or equal to 1/5 x minus 4, and the inequality -3x minus 4y is less than 16. So we have one inequality that's in slope-intercept form, one inequality that we're going to have to convert to slope-intercept form before we can graph it. Let's graph our first inequality here. And again, because this is purple and bold, you'll want to be writing this down. Here we know we have a y-intercept of -4, so we go down and plot our point at -4, and our slope of 1/5 means we move up 1 and to the right 5. So up 1, right 1, 2, 3, 4, 5, up 1, right 1, 2, 3, 4, 5, and we have our point. Now, once we have that, we have to look at, once we have our points graphed, now we have to look at our table. Here we see it's less than or equal to, so we find that symbol in our table. We see it's going to be a solid line, as you see on the right, and that we're going to shade below. So the shading is done below the line. We've successfully graphed our first linear inequality, but now we need to graph our second linear inequality. In order to do that, we need to convert our second linear inequality to slope-intercept form. So we're going to do that by adding 3x to both sides, which again, you'll want to write all this down so you have this as an example. Okay, once we add 3x, we know we cannot combine these two things. 16 and 3x are not like terms, so we just write them as 3x plus 16, because they're both positive. So we have -4y is less than 3x plus 16, and then when we divide by -4 to get y by itself, remember when you divide by a negative in an inequality, that inequality symbol flips, and so we get y is greater than -3/4 x minus 4. So if we look at this through the eyes of our slope-intercept form, that -4 tells us that that is our y-intercept. We start at -4. And our -3/4 slope tells us that we're going to move down 3 and to the right 4. So from that -4, we're going to move down 1, 2, 3, to the right 1, 2, 3, 4, and follow that pattern to graph our line. Now, because we knew that this was strictly greater than, we knew it was going to be a dashed line, and that we are going to shade above the line. So if you look here carefully at this dashed line, we have our shading going above that line. Now, to finish our inequality, we have to identify where does the shading overlap. So again, we look at our solution here, and the shading overlaps in this area colored in purple. This area represents our solution region, and any point in this area makes both of these inequalities true. Now, we're going to ask that you try one of these on your own. Go ahead and take a minute to graph y is greater than 2x plus 1 and 2x plus 4y is less than 12. Once you think you have this, call one of the teachers over to check your work. If you have questions, call us over as well because we will be talking about this as a class. Good luck, guys.